Okay, we are on 2018 FRQ number 1 is the graphing calculator section. It says people enter a line for an escalator at a rate modeled by the function r given by this r of t. Where RT is measured in people per second and T is measured in seconds. As people get on the escalator, they exit the line at a constant rate of 0.7 person per second. There are 20 people in line at time T equals 0. So part A, how many people enter the line for the escalator during the time interval between 0 to 300 seconds? So again, this is the rate that's given to us. So we're going to figure out how many people. Thus, you take the integral from 0 to 300 of the rate, right? And it is this first equation because this is defined for 0 to 300 seconds. So we will go part A. Okay, how many people enter the line? So number of people equals integral 0 to 300 of r of t dt. Okay, so again, we're going to use our calculator. No, not this, sorry. So math 9, and it was 0 to 300. Our r of t is 44 parentheses t over 100 cubed times 1 minus t over 300 to the 7th power, okay, dt. Okay, so enter. That is beautifully 270. Okay, so the number of people at in the interval between 0 to 300 is 270 people. Okay, all right, moving on to B. During the interval between 0 to 300 seconds, there are always people in line for the escalator. How many people are in line at 300 seconds, right? So you got to remember, though, you had 20 people to start in line first, right? So we had 20 people in line plus 0 to 300 of r of t, right? The rate of which is coming in. But then people are also exiting at a constant rate, right? So at a constant rate, so minus 0.7 times 300, because that's 300 seconds have passed, right? So how many people are in line at the end of 300 seconds? So we had the first answer. We have this integral from part A. So that's 20 plus 270 minus 0.7 times 300, that's 210. So it gives me 290 minus 210, that's 80. So 80 people still in line at t equals 300 seconds. Okay, all right, part C says for t greater than 300 seconds, what is the first time t that there are no people in line for the escalator? So remember, after 300 seconds, no more people will come in. So at 300 seconds, you only have 80 people left, right? So at 300 seconds, you only have 80 people left, and no more coming in, you're just leaving. You're just at the rate of the people exiting. So you just need to take the 80 people divided by 0.7 people per second, right? So divided by 0.7, that will give me about 114.286 seconds, right? So after 300 seconds, you need another 114 seconds to get rid of the remaining 80 people. So what is the first time? So you got to include the 300 seconds from before. So when does this happen? It happens at 300 plus 114.286 happens at 414.286 seconds. That is when, that's the first time there's nobody in line, because you got rid of the 80 people that is remaining in line. Okay, last part D. Between 0 to 300 seconds, at what time is the number of people in line a minimum? To nearest whole number, find the number of people in line at the time. Justify your answer. So let's see. The number of people in line, right? So number of people, we have that. So number of people is equal to 20 plus 0 to some sort of t, some time, right? And r of t dt minus 0.7 times whatever time it is, right? So it's the same time. It's at what time in the t is the same in both of these, in r of t and 0.7 times t, right? So remember, to find the maximum or minimum, we got to find the derivative of this, right? So again, I'm reminding you, you're going to take the first, take the derivative, and then set equal to 0, right? Because you're looking for maximum minimum. So we'll take the derivative of this function, right? This is my function. So number of people prime, right? So p prime equals, well, 20 is a constant. If I take the function, if I take the derivative of this would be r of t, right? If it's just this plugged in, right? F prime of b times b prime, f of b times b prime minus f of a prime. So that'll give us r of t here, minus a coefficient of 0.7. So really, setting it equal to 0, you get r of t minus 0.7. So when are you going to have a maximum or minimum? When you're going to have an extrema, when r of t equals 0.7. Okay, so we've got to use a calculator to find this and figure out when the t are, right? So r of t equals 0.7, so it's a little bit easier to go with the graphing style, but r of t is kind of ridiculous, but we're going to try our best, right? So 44 parentheses t over 100 cubed 1 parentheses 1 minus t over 100 to the 7th power. And when is that equal to? What do we agree with? 0.7, so 0.7. Let's give you a fun graph. So graph. Oh, that's not very fun to see. Oh, there you go. There you go. And you see on my graphing calculator here, we have two intersections. We have one here at x equals 33.013 and one more here at x equals 166.575. Okay. All right. Let's put that on our paper there. So when does that happen? It happens when t is equal to 33.013 and t equals 166.575. Now, we don't know these are truly maximum minimums because this is a closed interval. We have the beginning of 0, we have the end of 300. So you got to check against the y values of these two, and then you can figure out which one is your true, what are we looking for? Looking for the minimum, the smallest number, right? So if we make a quick t table, you say, all right, t at t equals 0, at t equals 33.013, at t equals 166.575, at t equals 300, what is p? How many people are there in line? So initially at 0, we have 20 people in line. We know that. At 300, we know based on part B, at t equals 300, we have 80 people in line. Okay, so the rest of these is, how do we know the rest of these? So we got to put them into the calculator and plug it into this equation right here. This is the equation we're going to plug in the t, right? So we're going to have plug in 33.013. So 20 plus the integral between 0 to 33.013 of r of t minus 0.7 times 33.013. So again, you're going to plug in your t, both of these, into that equation. And again, for the sake of time, you can try this on your calculator and double check, but you would get 3.803 for this first answer and 158.070. So that is actually a minimum and a maximum underneath, right? So, okay, so to conclude our part D, we're gonna say the number of people is at a minimum of 4 when t is about 33.013 seconds. Okay, about 4 people in line. Okay, all right, that's it for this problem.